Hello everyone. This is the second part of the video on modularity in architecture for games. It is the practical part, where I will break down this cottage into modular elements. For those who are new to the channel, this video is yet another episode in a large breakdown of my workflow as I develop this game-ready, intricate cottage in Unreal Engine 5 based on the concept art by Xiaosheng Bai, whose ArtStation profile can be found in the description below, together with my ArtStation profile. I do this work with respect to all the classical level and environment art principles, as well as relatively new Unreal Engine 5 technologies for environment art production. I would like to briefly describe what this video will be about and how we came to this. As I explained in detail in the first video on modularity, modularity is a scalable concept. We can build a modular city where one module is a house. We can build a modular house where one module is a story, or we can build a modular story where one module is a 2x2 meter wall. In addition, there are a number of factors that influence the necessity and scale of a modular system, and I refer you to the first video about the theory of modularity for architecture in games. So as for our cottage, I will decompose it into modular walls and roof elements. There are two main reasons why I will do this and not take the slightly simpler, non-modular, bespoke path. The first reason is that I'm going to use static nanite displacement mapping. So the number of nanite polygons, even on a relatively flat wall, will tend towards 10,000 polys. To make my occlusion culling and frustum culling work more efficiently, I will decompose the architecture a little more, but without going to extremes. The second reason is for practice, and purely for a show for the audience, for you. Since we are talking about modularity, it would be strange to choose a path with more bespoke geometry and to avoid showing how I handle the decomposition of the existing art blockout into modular elements in the chosen metric. If we appeal to real production, the work on creating a modular set will most likely look somewhat different. Most likely, we wouldn't have one house, but a whole set of cottages in a single architectural style, and we would create a single large modular kit based on several art blockouts and concept art. If this cottage is unique and exists as a single copy in the game, the need to decompose the blockout into modules remains only if nanite static displacement mapping is used everywhere. If not, then there is no real need for modularity. And I always urge everyone to assess the need for modularity based on the specific situation, which varies greatly from project to project. And again, I refer you to my first video on modularity, where the subject was elaborated. Now let's start planning and breaking things down. We'll start with the very element I outlined in the previous video on modularity, with this very wall. If you haven't watched the first part, I strongly recommend doing so before continuing with this video. And let me remind you that my grid in Maya is currently set up so that each cell is 1 cubic meter. And when I was making this art blockout, I tried to snap the faces of the walls to the grid as much as possible. It didn't work everywhere and all the time, because it was more important for me to grasp the proportions of the concept correctly, but in the case of this wall, it turned out more or less evenly. For the sake of transparency, I will say that I didn't count the meters or estimated the wall modules that we're now going to make while preparing this art blockout. Yes, I tried to snap the main walls to the grid, but I did not plan anything in advance that much. I think it is quite a difficult task to plan modularity and at the same time work with the architectural blockout based on the concept. Perhaps some people will find this reasonable, and I won't try to dissuade them, but in my opinion, it's too difficult a task, which I personally like to break down into different phases. Of course, it depends on the object as well. With simpler objects, where modularity is immediately apparent based on the structural logic of the architecture, It makes sense sometimes to plan modularity in parallel with the creation of the art blockout. But that's not our case. I'll start with the obvious, which is a 4-meter module with a window, like this. And now we need to decide what to do with this slanted corner. Since I made this corner bevel by the eye, it will be more difficult to calculate an even module with a width that is a multiple of 2 meters, and let me remind you that this is the metric I will be sticking to. For clarity, let's unfold this corner like cardboard and look at what we get. And we get 5 meters, which doesn't really suit me. And here we need to start calculating and evening out all the random values. Like with this corner face, for example. As I said, its width was chosen by the eye, and the 5-meter module itself is undesirable for me. I want to get something that is a multiple of 2, most likely 4 meters. We could just do it this way and get those 4 meters, but it will be a bad module with low reuse potential and would make further planning difficult. Look, if we put everything back in place, this is where the module ends now, and it's not even a half a meter cell, which isn't good. Here we need to find a way out, and this is how I would do it. Let's create a new plane. The length we need, 4 meters. But first, let's take a step back and change the width of the module with the window to 6 meters. Then we will have 1 meter here and 1 meter there. Next, we'll make a 4-meter module and then we'll figure it out. For now, let's snap to this vertex. Here, as I said, the blockout is not quite on the grid, but the width corresponds to the grid, so it's alright. And now let's rotate the cardboard. Again, it doesn't quite fit, but this is a blockout error. If we place it on the grid, everything will be correct. Now I'll make a bevel and fit it precisely into our blockout, also judging by the eye. Of course, this will slightly affect the UV unwrapping. And let's go back and work with UVs now. Our textile density will be 1024 per meter. And here we get 2 tiles per 4 meters. Everything is correct. The checker shows that everything is perfectly unwrapped. And now I make a bevel again. But now you can see my UVs are a little stretched. You can see that the checker squares are a little rectangular at the corners now. And we can do an unfold in the middle and thus slightly balance this stretch across the entire area of the module, thus significantly mitigating its negative effect. And now look, they are almost even, and no one will ever notice the difference or see this error on our textures, and it saves us time on calculations and planning. So now we have 2 planned modules. Let's move them aside and check them on the grid to make sure everything matches. Here we will also unfold the UVs, set the textile density, and it will automatically fit as it should, with the texture tiling 3 times. Here is a brief digression about textile density. I went a bit overboard with 1024 pixels per meter, because with that textile density, I won't be able to create adequate atlases for wood and stone later on. Right now, I'm still using a 1024 textile with a 2K texture for walls, but as I showed in the previous video, it's easy to halve the textile down by simply reducing the texture resolution to 1024 by 1024 in my case. This will give us a final textile of 512, which is a standard for third-person games. Let's move on. We count one from the corner and then take a 4-meter module. Here we get a slightly strange module with the window located in a random place, so to speak, outside the context of the cottage composition as a whole. But let me remind you of what I said in the first part of the video on modularity. I decompose the cottage into modular elements based on the fact that I want to ensure more optimal occlusion culling, since when using static nanite displacement mapping, each module will have from 8 to 12,000 polygons, and sticking to modular metrics, even for elements that are unlikely to be reused, is good practice, since we're working modularly anyway and not using a bespoke approach. This part remains. Let me remind you that we're only working on the exterior. The interior here will be quite primitive, and I will make it a single shell without displacement. We only need it for the light to work correctly. In general, I was a little confused by the concept that we would have such open windows in a small stone house in winter, which is probably not very practical and the hosts will freeze to death there. But anyway, we'll think about it later. Maybe at the end we'll add some medieval windows made of mica. We'll think about it. It would seem that we could also make a sharp corner module here for 4 meters. However, then we would end up with a 3-meter module, which isn't very good. Of course, there are all kinds of workarounds with scale on the grid in Unreal Engine, meaning that in theory, we could create a 4-meter wall module and downscale it by exactly 1 meter, since this segment of the wall is covered by a column anyway and it won't affect the visuals. But in reality, it is more advantageous for me to have larger modules, as they are easier to work with when painting masks in Unreal Engine. If you haven't watched the video about my layered material yet, now is the time to do so, and then everything that is happening here will be a bit clearer to you. So I'll just make a 10-meter module like this, and I'll mirror it in Unreal Engine to the opposite side, and that's it. I will emphasize again that such a module is not particularly convenient for constructing fundamentally new architectural structures in this architectural style. Its potential for reuse is lower than if it were a 4-meter module, for example. But in this case, within the scope of this work, I won't be able to reuse a 4-meter module either. And I'm also saving time by making one module instead of two, and it's easier to work with such a module when painting in layers in Unreal Engine. Here's our wall, all planned out. I can mirror elements on the opposite side using the scale in Unreal Engine, and not all game engines support this operation, but Unreal Engine 5 does as far as I know, and Static Nanite also works fine with mirroring using a scale of -1. But since we have everything done according to metrics, the modules will work even without mirroring, just with a 180-degree rotation. I'll ponder over what to do with this roof and this foundation. I would like to use the same logic and metrics for these elements as for the walls we just planned. And then in Unreal Engine or Maya, or partly there, partly here, I will be able to group these walls together with the roof and foundation into prefabs like this. Separately, I would like to talk about this slope on the brick. Usually such slopes in medieval buildings are essentially chamfers of the bricks that makes them triangular or trapezoidal shape. Here I have some references of something similar. It's not quite the same, but the essence is similar. Here the stones are the capstones, and they are triangular in shape, but in our case it will be a trapezoid. This element is quite suitable for baking it into a trim sheet. And we won't have that many trims in this cottage, but I would still use this technique and bake a few trims where it will be applicable and combine them with some bespoke baked stone elements and individual bricks. There is another interesting nuance. If I return my walls, which are already planned by the matrix, to their places and attach them back to the blockout walls, we will see a slight mismatch here. This is a completely expected error when working with our blockouts without planning modularity during the creation process. So we just need to take care of these areas now and keep them in mind. They are very minor, but I still like to correct the proportions on the blockout to predict any unexpected mismatches with other elements. Now let's move on to the roof and cut it into module corresponding to the resulting corner wall module. And we will do the same with the foundation. This is roughly what our module for this particular wall will look like. I will most likely import the roof as a separate static mesh, and I will import the wall, foundation and trim together as the second static mesh. At the same time, I'm testing out the UV layout for my elements. Of course, the geometry elements are not finalized yet, and this is still a blockout, so I'm currently planning ahead so that I don't end up in an unpleasant situation later on and forget about some problem or inconsistency. Here on the roof, we have these handy corner elements, thanks to which we can cut the UVs and not worry about correct modular tiling. The module is working perfectly now. Everything is covered with wood on top, you see, and there are beams underneath as well. And here, look, especially here, although there are roof shingles drawn here, of course they shouldn't be here, there will also be wooden supports there. We won't be putting shingles upside down, you know. The concept artist didn't focus on such details, concentrating more on the overall shapes, but we have to pay attention to such things. At least the really obvious situations that contradict common sense from a layman's point of view. Let me return to this beveled brick and clarify the details right away. I really like this example from the references with a small protrusion here, so I will make such a protrusion. I will press the wall inwards a little, which I think will look neater than pushing the edge of the trim outwards. And later I still push the trim outwards though, just a little, and this is made as a bit of reserve mass, since I am planning on sculpting the trim, so I'd prefer to just chip off the existing geometry. And finally, I will add a surface on top, where I can put some snow, and in general, it will work better with the brick wall on top. Next, I will turn on some music and simply cut out the roof and foundation blocks according to the measurements of our walls. I will immediately make a UV layout for the flat elements, and please use the timecode to fast forward through the video sequences. So the first building part of the cottage has been planned. I put my proxy modules aside and move on. And now we have the middle of the cottage and the wall with the doorway and windows on our agenda. And despite the fact that we have repeating windows here, and it would seem that we could divide this wall into 2 or 3 modules, in this case I will not do so. Firstly, I am very happy with the position of these 2 small windows, accurate to the centimeter. I spent a long time meticulously checking their position on the wall to ensure that it matched the concept art and suited my taste as well. Therefore, I'm not prepared to sacrifice any accuracy in order to create a single 2-meter module with such a window. And here I refer you again to my first video on modularity for architecture in games, where I gave examples from medieval castle architecture, and there we talked about the uneven distribution of windows, arches, and ventilation holes in walls, and how this affects the choice in favor of decomposition or vice versa. The second and perhaps most important point is occlusion culling, and in the case of this wall, we gain very little from decomposition. No matter which side we'll look at it from, in the vast majority of camera positions we will see it in its entirety and will not achieve any significant resource savings from breaking up this wall. Therefore, it will be a single module with obviously low reusability potential. But we will still follow the good manners and stay within the chosen matrix. So it will be either 14 or 16 meters here. For now, I will leave it at 14, and later we will simply bring it in line with the roof module. Now for the roofs. I will make the lower roof as a single 14-meter module, taking only one side, of course. I thought about whether it was worth splitting this roof into 2 modules, since the displacement of the shingles material will most likely result in more polygons than with a relatively flat wall. And I came to the conclusion that I would leave the lower roof as it is, as a single module, but the upper roof could be divided into 2 modules. And this is mainly because the upper roof has a greater area, which means that there will be simply more polygons after displacement, and it makes sense to decompose it a little. In addition, on the back side of the cottage, it will be possible to simply reuse one flat module without this cutout for the dormer. Next is an extension with a canopy and stairs. This wall module is thick, so we will consider how to proceed and whether displacement will look good on such module. I choose a width of 6 meters for this wall module. It will slightly penetrate the interior because of that. It could have been 5 meters, but we agreed to stick to multiples of 2 meters, and we also know that in our game the interior will not be accessible to the player. I will also reuse the existing trim we already planned, and perhaps even the foundation module of one of our wall modules from before. We'll see about that. With this roof, I thought about creating 2 modules, for example the front and side sections of the roof, and duplicating the latter to the opposite side. However, this won't give us much. The size of this roof is comparable to our 14-meter piece of the neighboring roof. It might be a bit heavier in terms of polygons, but again, nanite occlusion culling should work well and cut off invisible polygons. So to save time, I would leave this roof as a single piece. In addition, we won't have to worry about the metrics of these modules, as this roof has rather unique proportions, and bringing them to the matrix could disrupt the composition a bit. So it's time to deal with this extension of the building. We have a corner with 2 window slits, a doorway under a canopy, and a whole backside. I will emphasize once again that I built the art blockout based on the concept, trying to match the proportions by 80–90%, and when creating the blockout, I did not focus on metrics or snapping to the grid, therefore I have to do that now. It would seem that we have just finished decomposing this left extension by our metrics and everything went quite easily. But let's see how things stand with this extension. Let's copy it, bring it forward and snap it to the grid. First, we have thickness here. Let's think about what to do with it when we finalize the modules. I will probably make the interior a separate, unique static mesh without displacement, or if there is no displacement on this extension and on the outside, then we can make modules with thickness. Secondly, you can see that this structure is not aligned with the grid, so we need to refine the metrics. Now let's make another copy for better comparison and convenience. I moved the right wall to the right, snapped it to the grid, and as a result, one side of the cube became 10 meters long. Next, let's calculate and plan. Look, if I put 3 meters on one corner, the module will be then 6 meters in total, which is what we need, and 3 meters on the second corner module without windows. Then the module in the middle will be 4 meters, which again suits me perfectly. Let me remind you that I'm measuring along the outer wall, which is not entirely correct. If you're making modules with thickness, it is better to measure along the inner wall, but we agreed that in our hypothetical game, only the exterior of this cottage matters, plus I will most likely be making modules without thickness. And what is happening on the other side of the cube? Here too, we are not standing on the grid. We will also have to change the position. Here too, it will be most convenient to extend the wall further and get the same 10 meters. So we have 3 meters here, 4 here, and 3 at the corner. The same here. This allows us to reuse quite a few elements. Here will be our first module, the second module with windows, and our third module. Oh, and I almost forgot the fourth module, a wall with a doorway. So in total 1, 2, 3, 4. Okay. Now let's see how our changes to the walls will affect the roof. Let's try to understand how many problems we have and whether we will have to remodel the roof. Along the z-axis, it's simple. We move the roof to the new position of the wall, but along the x-axis, it's a little more complicated because it changes the thickness of the roof. But let's try to work around it as it is first, and then we'll assess the situation. Now I'll copy the edited static mesh and place it directly on the art blockout to reassess the situation in terms of composition and figure out what problems and nuances we have in connection with the change in proportions. I will put the art blockout extension in one layer and the new version in another layer, and now I can easily switch between them. And it is immediately apparent that the chimney is clipping, but this is the smallest problem and can be easily fixed. The biggest problem, however, is the thickness of the roof. It was obviously already thinner than it is now. In the concept, the roof is also quite stylized, with a very narrow top. And we will either have to accept this change in proportions or slightly remodel the roof blockout. At the same time, I noticed that I have problems with the symmetry of the roof. So let's figure out how to deal with all this. This new roof thickness bothers me a lot, to be honest, and it appeared as a result of moving the wall forward by a meter. First, I'll try to reduce the thickness of the roof itself. The result is generally satisfactory, but we're still losing symmetry here. And I don't see this as a big problem in the yard blockout, but if we look at the concept, I think there will be a problem. When adding details and beams, we will have problems in this area if we don't fix the symmetry of the roof. However, if we simply restore the symmetry, there will be an ugly protrusion here. This whole situation is a good example of the problem with proportions that arise when decomposing an existing design into modular elements. And we may get around this in every way possible. Sometimes you can just leave it as it is. But let's try to be clever in some other way, purely for the sake of sporting interest and exercise. And all the problems are, once again, because of this 1 meter. And you can see it clearly here at the switch. Now let's go back to our part of the building here and try to think another way to possibly preserve the original proportions of the yard blockout. Let's put this wall back in place. And here's the thing, we actually end up with half a meter here. Let's move the wall again, but this time exactly half a meter. Not just the wall itself, but the entire element, keeping the corner module unchanged. And we get this wall, which is not 4 meters long as it was before, but 3.5 meters now. And the trick is that in Unreal Engine, we can scale modular elements with a grid reference. But a small disclaimer first. This is not standard practice. It is better to refrain from scaling modular objects. However, in rare cases, it can speed up the work, and if you know what you're doing and are sure that it will have a positive effect on the result, then why not use it? Here in Unreal Engine, I'll take this test module. I don't mind that it has a window. It is better not to scale modules with windows. By the way, if you didn't know, there's a very handy hotkey called Snap Origin to Grid in Unreal Engine. If my mesh, say, is somewhere in a random place, and I press X, and the mesh snaps to the nearest grid point, you can assign a different hotkey. I don't remember if there's a default key. The name of the command is Snap Origin to Grid. So let's get back to scaling with grid snapping. I can move along the grid, everyone knows that, and I can scale along the grid. Right now I have a step size of 0.1, which is 20 centimeters, but I'm interested in this step rather, 0.125, which is 25 centimeters, with which I can scale the module down to half a meter. Of course, we'll get some distortion on the texture, but that doesn't bother me at all, since we're only going to scale two identical modules of a flat wall. Moreover, these modules are almost invisible on both sides. One is covered by a chimney, the other is completely inside the room. Of course, if we were building a house with an interior, this scaling technique wouldn't work so conveniently, and we would have to redo the roof. Now let's take the original roof again and edit it to the new proportions with this 0.5 meter scaling of the wall module to be done later in Unreal Editor. As for the foundation, I will most likely reuse elements from the modules on the left extension. I may be able to make do with what is there, or I may get a 6-meter corner module. We'll see about that. I won't be doing a separate module for this foundation just now. As the saying goes, measure 7 times to cut once. I will separate the modules and move them to my pool. For now, I will leave the thickness of these modules as it is. I'm a little concerned about how our nanite displacement mapping will look at the corners of these thin windows. The thing is, the neighboring modules, in the concept, have this decorative arched brickwork, but it's not used on these windows, and to be honest, it would look completely out of place there. So for now, I'll leave the thickness of the modules and test what to do next. I will divide this high roof into 2 major modular elements. The joints between them will then be covered with corner shingles, and we will think about how to do these shingles when we will be making the atlas. One interesting point about setting the pivot for such objects: for ease of use, I will set the pivot of each module along the central axis of the entire roof in assembled form. Similar to some radial modules when working with cylindrical objects, this is, in my opinion, the most convenient way to assemble similar structures. The proportions are a little off here, so I will try to fix the symmetry now. And now I will refine the proportions of the buttresses a little. They are currently thicker than necessary and lack details at the base. Now, we're left with what I called reusable standalone elements. For example, a window sill, this large stone, a small window sill, this arch, and this arch. We will also need some kind of edge mesh, edge brickwork for this foundation element. By the way, I was thinking about these unusual triangular arches. I even did a little rev dive to plan how to deal with them, and well, I found a couple of options. This, for example, is a rough version, but you can see everything works, the doorway is standing, and I also found this neater option, which I think will suit us very well. I would like to texture all these stone elements by a single texture atlas. Perhaps we will have some space left, and I will include one or two trims for different tasks into this atlas. And actually, to determine how many objects and with what textile density will fit into our single atlas for stone elements, I will start right now to group the blockouts of these elements and immediately estimate how much space they will take up on the UV layout. This is basically planning an atlas, and it is perhaps one of the most important tasks at the modular decomposition planning stage. Because while we can handle geometry quite freely, within reasonable limits of course, we must always be careful with texture space. Textures are always more expensive than polygons themselves. If we want to achieve good performance, the key to this is optimal work with textures. Here, I'm trying to slightly edit the proportions of the window sill in order to reuse it for another window opening. And in general, the idea is to reduce the number of unique elements in the atlas. The more geometry we can reuse from a single texture atlas, the less texture space we will need overall to meet our needs. Here we will need two brickwork elements for the arches. They can be mirrored along two axes to save texture space and avoid unnatural symmetry. Both of these elements can be made using trims. Or we can also bake slightly more unique pieces that will still be reusable. We'll think about that later. A small disclaimer: there are different approaches to working with trims and atlases. I will stick to the simplest and most straightforward approach, which is perhaps a little outdated, but in my opinion more convenient when working with nanite geometry and with historical architecture like we have. There are different approaches to working with trims. For example, an approach using two UV channels, where one channel contains edge trims and surface decals, and the second channel contains stylable surface details. Then normal maps from both channels are combined in the shader. Or a fairly popular approach using floating mesh or edge decals. But for this project I will stick to the simpler route with bespoke baked normal maps for blocks of stone. Perhaps I will blend this normal map with detailed normal, thus still using my layered material. We will see in the future. So this is the set of stone elements I ended up with, and I planned the texture atlas behind the scenes. Now let's take a look at it all. It includes trims for arches, stone slabs for window sills, and trim for the foundation. Right now these are just placeholders still, and it may not be entirely clear what each element is for. For example, this is a future piece of brickwork for window frames. There is a cutout you see in the back to save some texture space. You see, we don't need anything behind the wall here. These two elements are window sills. First, I trimmed the bigger window sill a little to use only the visible part. Plus, I cut these slabs in half because with the textile density 512 I chose, such large slabs didn't fit into one atlas with other elements. Of course, in theory, you could just create a new material for them, but that's the easy way out. I would like to stick to what I consider to be the optimal plan, and use one atlas for all stone elements and one atlas for all wooden elements. The fact that I cut them in half and will only bake one half means that one side will be mirrored in the final model. Of course, this mirror symmetry will be somewhat noticeable, but I find it acceptable for elements such as these window sills. Here we encounter a common trade-off in working with game environments. We need to prioritize and choose the most optimal path, taking into account the three values I mentioned in the previous videos: performance, visual quality, and production speed. In this case, I will sacrifice visual quality slightly in favor of performance and production speed. But actually I have an idea of how to level out this butterfly effect, meaning mirror symmetry on the texture, using our layered material. And this is what I ended up with on the UV layout. Right now everything is laid out a bit haphazardly, but this is just the planning stage for the atlas. Later, when the models are finalized, this layout will be redone from scratch. You see, I originally wanted to add even more elements to the atlas to diversify my stone surfaces, but in the end, they didn't fit. This means we will have to make do with what we have in the atlas, only what fit into it. These vertically stretched UV shells are my future trims. They will only tile vertically, which allows us to use models of different heights with one material. The window sills will be baked uniquely. This element, also laid out in trim, will be a flat stone slab which I showed in the reference for arches, and this element will be the trim on the top of the foundation modules. Here. Textile density is 512, as I mentioned, standard for third-person games. Don't pay attention here, I just stretched the UV shell purely for clarity to understand what the trims are. However, these window sills have a slightly lower textile density. If they are 512, they will no longer fit into this atlas. And again, I make a decision in favor of optimization and reduce the textile. A reduction or increase in textile within the range of 15–25% will most likely remain unnoticeable without a thorough analysis of your graphics by a professional environment artist. Therefore, in games we try to focus on certain fixed values, which are especially important when dealing with tileable materials. But in the case of uniquely baked elements, we can afford to deviate slightly from the rules, because again, the human eye, especially the player's eye, will never see the difference. Through trial and error, I put together a plan for a second texture atlas behind the scenes. This atlas will include all or almost all of the wooden elements. And let's go through these selected elements, and I'll show you what they mean and what they're for. First, these three objects. I understand they look a bit strange. This element will be the foundation of a large wooden column. It's here. I would like to sculpt some wood carvings here and make this element a bit more attractive, even though on the concept image it is just a straight log. I think it's an interesting idea to break up the column in terms of texture and detail, especially in the area of direct contact with the player and the camera. This foundation is here on the texture. This element, this log, will be made as trim. And when I say the word trim, what I imply is, in my case, a vertically tileable stripe of texture. It could be tiled horizontally as well, it doesn't matter, but the difference with an ordinary tileable texture is that we can have multiple trims on a single texture. And this will be the simplest element, just a strip of wood texture without any chamfers or special details. It will be suitable for such elements. Perhaps we can apply it here. Perhaps even this entire part can be remapped into this one trim. In general, this is going to be the simplest, most basic texture for wooden elements that I will not be able to make with a bespoke, baked, normal map or other trims on this atlas for one reason or another. There's one more trim. Right now it's a trim, but I'll think about it some more. Maybe I can forgo vertical tiling and lay it out only on the half of the texture, freeing up some space for other needs. But for now it's a trim. And here's what it's for. You can see the shutters here. They consist of separate planks nailed together, and in essence, this trim will be these 4 planks. The planks correspond to these polygons, you see. This trim will help me to quickly and efficiently cover all the shutters, of which there are quite a few in the concept art. On the windows, here, here. Others are visible in the gaps. So overall it will be a useful element. Again, remember we said that we won't leave the shingles here, but we'll cover it with planks and beams to make it more realistic, and so on. I should note that, in theory, this could be solved with individual planks, simply by copying and pasting bespoke, baked 3D models of planks, but I still decided to work a little old school in this place and save on polygons, especially since we have enough space on the atlas for this. We've talked about these 3 elements, now let's talk about the other 3. And here I'm not going to save too many polygons, and I'm counting on the efficiency of nanite. These 3 beams, as you may have guessed, are meshes from Quixel Megascans. Here's one of them as an example. It is worth mentioning that I have already optimized them a little. Initially I took lot 0 from Megascans and then used the reduce operation to reduce the number of polygons until there were no problems with the model's shading. You can see that there were 10,000 polygons and now there are 3,500 with absolutely no loss of quality. If you haven't used the reduce command in Maya, it's extremely useful and I recommend trying it. It's a bit demanding on locked-unlocked normals in Maya, but I have a script that restores the vertex normals of models no matter where they were imported from. Reduce can optimize the mesh very effectively when working with organic shapes or scans. If you use it too aggressively though, it will break the shading, so stay alert. Next, there is a problem when using Megascans models in game projects. When we download a Megascans 3D model, it usually comes with its own unique texture. For example, this is the texture of one of the beams, and it only includes this beam. This situation is not suitable for games, as we cannot assign an individual material to each beam. We need an atlas for a group of objects. The more objects we cover with one atlas, one material, the better it is for performance and for long-term production speed as well. Therefore, I will reassemble these pieces of wood. I have already laid them out on a UV map. While this was done as part of the atlas planning, later it can be laid out more neatly, more optimally. The idea is that we will rebake the color, roughness, and AO textures from the original UV layout to the new UV layout so that the original textures aren't lost. But this won't work for the normal map, so we will have to bake the normal map again. Fortunately, Quixel generously shares the source files and we have access to high poly models of these beams. And I still have a little space left here. I would like to use this space for the rope trim. You can see that we have it in our concept art. And this space could be used for some kind of ordinary sheet metal. This is needed for all kinds of staples, nails. Maybe we can even make these lanterns using only a small metal patch here. And as a general rule, it's always a good idea for the atlas, which is positioned as atlas for all wooden elements in medieval architecture, to have a little rope and metal on it, because in real life these materials are often used together, and you'll probably be in need of small amount of metal and rope every time you build things out of the wooden beams and planks. By thus, we save quite some draw calls, of course.